Okay, let's look at the homework 1, problem number 4, part A. Alright, so let's use a Gaussian elimination to solve this system of linear equations. Alright, so first we have to come up with the initial matrix. So it's going to be 1, 2, -3, -4. Then right hand side is 6. And you have 1, 3, 1, -2, then right hand side is 4, and 2, 5, -2, -5, and the right hand side is 10. Alright, so let's work on the first row. Alright, the pivot is right here. So pivot, it's already 1, so we don't have to do anything with that, but we need to turn these guys into 0. So this guy into 0, and we have to turn this guy into 0. Alright, so let's do that. So in order to do that, we need the operation. So we use always the pivot to turn these guys into 0. So let's turn this guy into 0. Right, pivot is in row 1. So we put the row 1, right? Then you always multiply by the negative of the number you want to get rid of. So I want to get rid of 1, so it's going to be -1. Then add it to the row that you want to change. So row 2 is the one we're working on. So row 2, right? Same deal. So we want to get rid of 2. So we multiply row 1 because row 1 has the pivot. Multiply by negative of the number you want to get rid of. Then add it to the row that we are working on. So in this case, row 3. So that's going to replace our row 3. Alright, so this is going to give you equivalent to matrix. So here, so we have a new matrix. And we're not changing the first row in this case. So I'm going to just copy the first row. 1, 2, -3, -4, 6. Alright, so let's do this. So this is going to be a 1 minus 1, so it's going to be 0, which is what we wanted. 3 minus 2 is 1. 1 minus -3 would be 4, because adding 3. Alright, -2 minus -4 is adding 4, so it's going to be +2. Right, then 4 minus 6 would be -2. Right, and here we multiply the first row by -2 and add it to that. So 1 times -2 added to that is 0. Right, so 2 times -2 is -4. -4 added to 5 would be +1. Right, -3 times -2 is +6. Added to -2 would be +4. Right, -4 times -2 is +8. Added to that to -5 would be 3. Right, so multiply 6 by -2, which is -12. Added to a 10, so it's -2. All right. So we are all done with the first column. So this will never get messed up. So we'll keep that as it is. Then look at the next pivot. So go to this second row. Go to the first non-zero element. And luckily, it's already 1 again. So what we need to do is we need to turn everyone else in that column into 0. So this has to be 0. All right, we want this guy to be 0 as well. All right, so let's do that. All right, so in order to turn this guy into 0, again, we always use this pivot. All right, so pivot is in row 2, so we're going to multiply row 2 by negative of the number you want to get rid of. So we want to multiply by -2, right? Then add it to the row that we are working on, so it's row 1. All right, so in order to get rid of that, you multiply row 2, because row 2 have the pivot again, and multiply by -1 and add it to row 3. All right, so we have that. All right, so let's do that. So that's going to give you the equivalent matrix. So another matrix. All right. All right, so nothing happened to the second row, so I'm just going to copy the second row. 0, 1, 4, 2, -2. Right? All right, so we multiply second row by -2 added to that, so it's 1. Right? 1 times -2, -2 added to +2, so 0, which is what we wanted. All right. 4 times -2, -8, added to that is -11. Right? All right, 2 times -2 would be -4, added to -4 would be -8. Right? And -2 times -2 is +4, added to 6 would be 10. All right? Then here we will multiply by -1 added to that, so this is 0. So it's basically 1 minus 1, so it's 0, right? So 4 minus 4, it's 0, kind of nice. And 3 minus 2 would be 1, right? -2 minus -2, that will be 0. Right? So we are done with the first 2 columns, right? So go to the next row, so third row, look for the first non-zero element, which is actually 1, right here. So again, we don't have to do anything, it's already 1, so we have to turn these guys into zeros. So this guy also goes to becomes 0, right? So what we need to do is we just take row 3, because row 3 has the pivot, right? Then you multiply by -2, then add it to row 2, right? And take row 3, multiply by -8, so multiply by 8, and add it to row 1. And that's going to be our new row 1, right? Then we're going to get to the next matrix. It's going to be the final matrix, all right? And you're going to end up getting, right? Nothing happened to the third row, so I'm going to keep that. It looks nice. 0, 0, 0, 1, 0. Right? All right, so what happens is we're going to just multiply. Let's see, let's work on the second row. So multiply for third row by -2 added to that, so 0, so it's going to be the same. And multiply 0 by -2 added to 1 is still 1. All right, multiply 0 by -2 is still 4. All right, multiply 1 by -1, -2 added to 2 is 0. All right, multiply 0 by -2 added to -2 is -2. Right? Right, so now we multiply third row by 8 added to row 1. 0 times 8 plus 1 is 1. 0 plus 8 plus 0 is 0. Right? 0 plus 0 times 8 plus -11 is -11. Right? 1 times 8 is 8, added to -8 is 0. Right? 0 times 8 added to that is still 10. All right. Then we can stop here. All right. Then what we want to do is, this is a reduced row echelon matrix. And what we want to do is we're going to turn this into an equation, right? So we so first row corresponds to this equation, right? Remember that the first column corresponds to x1. Second column corresponds to x2. Third column x3, and fourth column x4, and this is the right hand side. All right, so you will have this equation. So if you translate that into equation, it says that the x1, right, 1x1, there's no x2, and negative 11 x3, and this is equal to 10, right? And the second equation says that this is x2 plus 4x3 and is equal to negative 2, right? And the last one is x4 equals 0, right? And at first, I'm gonna just rewrite this. I'm gonna just solve the first equation for x1. So I'm gonna just add the 11x3, and that way we can write it as x1 is equal to 11x3 plus 10, right? And the second equation becomes x2 is equal to, so I'm going to just subtract 4x3, right? So it's going to be a negative 4x3 minus 2. All right. Then you notice that you can see that, let's see, x1 has to have a certain form, and x2 has to be a certain form in terms of x3, and x4 actually has to be 0 all the time. All right. Then you notice that there's no condition on x3, right? So that's why x3 is called the free variable. So x3 and this one. So those are called the free variable. Which means that x3 could be any real number you choose. All right? But once you choose the value for x3, x1 has to be a certain form, x2 has to be a certain form, x4 is always 0, right? So here's the solution. So there are infinitely many solutions because we get to, you have infinitely many choices for x3, right? So here's how we write. So the solution is going to be, so you have x1, comma, x2, comma, x3, comma, x4, right, is equal to, right? Right, so first we're gonna have to use some variable for a free variable, because free variable can change. So x3 is a free variable, so I'm gonna call let's say let x3 to be t. Then you say where t is any real number. All right. But once x3 is determined to be t, then x1 has to be 11t plus 10. So you just write down the expression 11t plus 10, right? And x2 would be negative 4t minus 2, right? Then x4 is always 0, right? So this is the solution of the linear system of linear equations, right? So I'll just box that in, right? And but there are infinitely many solutions because we can choose any real number for this variable t. All right, that's it. I hope that this was clear.